Vision language models lately have created a lot of hype throughout different kinds of applications, and I was always curious to try the vision language models on autonomous driving datasets and see how they perform on autonomous driving scenes. So in this video, I've tried the Microsoft's Florence 2 model on autonomous driving datasets. So stay tuned until the end of the video. Welcome back to the channel, guys. My name is Dhruv. I am an engineer at Convolve, and at Convolve we assist all small, medium and large enterprises with their CV computer vision AI needs. So if you ever want to get in touch, here is the contact information. Feel free to email us, feel free to get in touch with us, and we would be happy to chat with you to look at your problem and to offer unique solutions. So guys, here on the screen you can see the notebook that I've created to use Florence 2 on autonomous driving dataset, and specifically I have tried the object detection task for Florence 2. That is the task that I am trying this particular Florence 2 model application on. I've also tried a little bit of segmentation, but I didn't go too much in detail. So in this video, it's mostly about the object detection. In order to use this particular use case for this particular experiment, I have used Pandaset. So for those of you who are not familiar, Pandaset is autonomous driving dataset by Scale AI. You could download it from the internet. I was not able to find the download link from Scale AI website anymore, but Kaggle has that data set over here. They have a bunch of sequences, around 70 or more for different scenes, and you can use them. For this, I just use scene number 1 for this experiment. So here, first of all, the first step is to import all the required libraries for transformers and for Florence 2, and here we are defining the model type. Here we are using Florence 2 large model. So we essentially load the weights, pre-trained weights for Florence 2 large, and the weights for the model and the processor. This function here is just a function that is used to run inference using the Florence 2 model. The way it works is you give it a task prompt, and that task prompt is the task that you want it to do. In our case, for example, we want object detection, so we will give it OD as the task prompt, and then a text input. For some tasks, you can give it a subsequent relevant input that can be used. So now essentially what it's going to do is it's going to give the processor the prompt for the task that we're trying to perform, and it's going to generate the output. So let me show you maybe an example here. So for Pandaset, first of all, in order to use Pandaset, that dataset requires an API that is very easy to install. All you need to do is clone the repository for Pandaset devkit. And then after installing, there is setup instructions over here. You just need to git clone the repository cd into the Python folder, and you just do pip install dot, and it will install the devkit to your environment. So once you've installed the devkit, then you can just import the dataset class within Pandaset, and you can use it to load your Pandaset dataset. And it's as simple as doing load camera, and all the images are loaded in the memory thereon. Now this is a good thing because it's easy to use, but it's a bad thing because it loads up everything on the memory, which may lead to high utilization of your RAM. So essentially all we do is, for example, we load the image, and let me show you what this image looks like. This is what the image looks like. It's a scene where the ego vehicle is moving through a street, and there's so many other cars. Then we essentially define the task prompt here, which is OD, and then we run the results. We run the particular task on that image. So once we run this on this image, here we have the code to plot the results on the image using bounding boxes, and after we run that, we can see that it is able to detect cars here, it is able to detect all the cars here, all the cars are detected, but we have some false big detections here as well. However, I believe if we are to use some sort of filtering, we can filter this big anomalous detection, because it's pretty easy to say that usually a car would not be this big, right? So somehow using some filtering techniques, you can filter out these false detections, but essentially this is what we get. Now I wanted to run at all the images, so I get the total number of images in the sequence that we are dealing with, and then I essentially just loop through all the images here, and I say that this is the task prompt for object detection. Run the example on that particular image and save it in this output folder. So once I run it, everything is saved in this output folder, and we have the output in that folder for each of the examples. So these are the output images saved here. Now that we have the output images saved, it's just easier to look at the video. So we use FFmpeg to generate a video out of it, and then here I have essentially loaded that video. So this is what it looks like. Let me play again from the beginning. Right, so throughout the series, throughout the sequence, it's able to detect the cars. Those initial false detections do stay for some reason, but almost all the cars are being detected. And guys, it has never seen this data before. It has never been trained on this data, right? So it's just a vision language model. We are telling it to just do object detection on this in this data set. Now keep in mind, it's not just an object detection model. It has a lot of other functionalities as well: captioning, detailed captioning, phase grounding, segmentation, region segmentation. So it's despite of all these functionalities, it's still able to do relatively okay on this unseen data set for object detection. I thought of trying for segmentation, so I just load a random image, give it a task of expression segmentation, and tell it to segment cars, right? This is the code, and by the way, all this code will be on our GitHub repository. This code essentially draws the polygon. So based on the results from the Florence 2 model for segmentation, its job is to draw the polygon. And let me show you what the result looks like. So this is the image output. And it was able to segment this image. Now it wasn't able to segment all the other cars, but it segmented this car. Now of course, if I were to try a little further, I'm sure we can give it the prompts to find all the cars, or we can do a cascaded setup wherein we give the model the bounding boxes from the object detection output and tell it to segment cars within that. That way the Florence 2 model has the task to specifically segment regions based on the regions that the user inputs. So based on the bounding box outputs from object detector, you can use that output towards the input for segmentation and do better segmentation. So essentially this was my application of Florence 2 on Pandaset. Again, you could try other autonomous driving datasets as well. With this setup and with this kind of implementation, you can introduce the datasets you want and try Florence 2. Now a few takeaways from my end. I think the model does well with regards to unseen data it has never seen before, and it's able to work on the AV dataset. The drawbacks though are the inference time is very large at the moment. It took me some time to run inference per image on these images from Pandaset. Of course, in autonomous driving, you are looking at real-time performance. That's what is desired. So if there is a lag, if it's not real time, that may not work in most of the use cases. However, with time, I believe these vision language models are going to keep getting better and better, and with these foundation models we can achieve a lot going forth. That's it for this video, guys. In summary, we've talked about Florence 2 and its application on AV dataset. I have showed you how you can apply this on a specific autonomous driving dataset such as Pandaset, and I shared with you the results. Feel free to use the notebook from our GitHub repository. The link is in the description, and you can play around with it and see what you can do with it. If you like this video, please hit the like button, subscribe to the channel and hit the bell icon so you are notified about any new video that we upload. Thanks a lot for watching, guys, and I'll see you in the next video.